All right, so this lecture is about the lab that I assign you to do, and then also the project is related to the project 3. And since some people did not understand properly about VBO, I thought about going over this and then see whether you can get a better idea. So this is something I posted online, so we can go and download that. I already downloaded here. Let's open that, and we're going to apply some of the things here and see whether that works for us. Okay. All right, so let me open this on Code Blocks, of course, and then see what is the structure and how we're going to take care of it, right? Okay, so right, let's copy the file that I have. Control A, Control Z. All right, and then let's have it in my setup here, which is how I'm going to work on right now. So that's the file I have, and then Control A, Control V. Okay, so this is the file I have. So we're going to do a little bit modifications on this and see how that we can apply normal and just the normal, just to give you a little exercise on this, right? Think we have to do enable these when, because you're doing on Windows. So the glue static has to come before the glue edge, obviously. So this has to go up, otherwise it will throw an error, obviously. So it has to be this order on the glue part, and then we come down all the way, and glue init enable. Okay, so then the translations here, let's make it a little closer by changing my z-axis. This is too far, so let it get it to 2. It's much better. So let's run this where I have all that set up for you to just alter a little. So that's what I did, gave you as the lab assignment. Right, so let's see how it runs, and then we'll carry on from there. Right, so it's coming up. Okay, so this is what you have. I don't think it has the proper look on the triangles. You can see the normals look off, right? It's not pretty right. You can see that when you rotate it, right? Well, I'm not sure whether I can get it properly on this lecture, because it's a quick lecture. I did not test it. I'm just going to write it for the first time, just to introduce that, how you're going to fix this. So all right, so let's get started. I'm just going to introduce some the points on VBO. So I do a code through walkthrough on the code, and then what we can do, what is the concept behind it. So that's what I'm going to do. Okay, so the first thing is, first thing we have to understand is what is this VBO thing, right? So let's talk about that a little here, and then we'll carry on. So in this code, what we have is a cube. I just comment this part out, but we'll talk about that. We will uncomment this maybe, and reconstruct the structure, right? All right, so let me introduce the VBO part on this. Okay, so how we're going to structure this, that's what we're going to look at. Right, so so we have to put these vertices in one array, right? And then we're going to put these normals But the problem here is, the idea here is, if you have an object like this, right, the first thing you have to know, these are individual points, right? And what we're going to do, what is one object of this is, yeah, I can have my xyz values, which is v values, right, for this point, and then also I can apply my normal values, which is n value here, and then if I have texture code also I can apply here, right? So that means I can put these coordinates. One thing you have to make sure, these numbers, like for example, if you get a 1 point here, that point has one normal and one texture. So this one normal means you're not going to take the surface normal. So there are two kind of normals. One is the surface normal, the other is vertex normal, right? So we went through, if we having something like the vertex normal, that helps you to make sure that the edges are not giving you some the effects, right, artifacts. So in that case it will be more smoother. So that is one way of doing this. I will introduce that way, which is called draw array elements. So that's what we're going to do, or the draw arrays. There's another one called accessing an element of an array individually. So in that case we can use the face normals, obviously. But here let me introduce one way, so we can stick with one thing first and then we'll move on to the other, right? So if you take one vertex, one normal and one texture for each of these, that means the number of values for each of these guys, I have to match this one with its own normals and its own textures, right? And so this guy also, right, n's and t's. So when you do that, if you have, how many you have here, 1 2 3 4 5 6 7 8 into 3 is 24 elements I have, right? So what you have to do is make 24 elements for your v's, make 24 elements for your n's, and make again 24 elements for your t's as well, or the colors, whatever. So this is the first thing you have to do in order to make sure your VBO runs smoothly. Okay, the reason for that is actually when you're talking about indices, these indices are only bind to this one. So that's what the indexing is, right? So that indexing means I have two things, that one is we call VBO in this case, and the other one is I call IBO, right? That is, the other one is IBO. So those are the two things I'm going to use here. So the VBO will be 24 elements of V's, right? And in my case I don't have texture here, so the 24 elements for my corresponding normals, right? So that's what I'm going to use here, right? And so if I have these two, then I will have one index which is actually point to this one over here, right? That is all. So then the corresponding VBO, if I have a corresponding VBO for this guy, which is on here, I mean the corresponding normals for each vertex, that's what I mean. So if I can access this, then the next step is it will pick up automatically its own normal here, right? So that is what we're going to use in this case. So so this index will connect it to the V, and the V will connect it into the normal and then access that. So this is in order to do this structure like this, we have to rewrite our normal coordinates what we have is only 6 elements here, right? So this is a surface normal. So surface normal means if I have a cube like this is the normal is giving. It's more precise for the cube kind of things, but for the teaching purposes I will show you how you really going to do it in this model right here. Okay, so so that means I had to expand my normals differently. I had to address that differently, right? So that's the one thing I had to do here in order to make it happen the way the one way of writing these things. Okay, so well, if you write it like the way that I'm suggesting you to do in this case, I mean teaching you to do in this case, I think you can use array GL draw elements directly and then 36. At here this point you can change these to different ways of writing, like you can access array element with the for loop if you want. If you want to do it like that, maybe you have to address it differently. In that case the structure won't be the same as this, it can be something else, right? Okay, so let's look at how we're going to arrange my VBO in this case, right? So this is the first thing I'm going to do, right? So let's do the walkthrough on the code and then see what we can do, right? Okay, so this is how I start my code. I have vertices here we call verts, right? And the normals, if I have it like this it won't work, right? And here I just altered this one a little, which is I'm just getting out only the vertices. Well, it's starting from 0, so just subtract 1 and then extract this. So that's what you see in your structure right now. Okay, so well, I ask you to alter this, modify this, that you can access normals as well, right? So that is what I ask you to do in your as a lab assignment, because it would give you a more idea how the VBOs are working. Okay, right. So in this case, let me rearrange these things. So yeah, obviously I'm going to use this one. So right, so I'm going to uncomment that and comment the bottom one. Okay, and from here to over here, right? Okay, so we're going to create this one. So why I comment this one? Well, we're going to create 2 of them, right? So the first thing I'm going to create here is nothing but array for my index for the vertices, right? So that's what I'm going to do. So index for the vertices is int, obviously. It's an int value, right? And I can call it indices, so it's indices like that, right? And then let's set it to 36. I know already this is for 36. This is just for you to understand what I'm doing here, right? Okay, so then obviously I need the float to store normals. So how many normals I need? Well, I have xyz values like that, and I have 8 of them here, right? So it is 24 elements here. So I need 24 elements for my normals. So normal, let me say like that, and this will be initialized with well, 0.0 comma like that. I think I need 24 of them, right? Yeah, so for this case, right? So I'm just giving you a demo here. So 3 4 7 8 9 10 11 12. I guess I have enough, I believe so. If I have too much uh, let me see whether I have right. 1 2 3 4 5 6. Right, so that is 24 elements right there, right? And these are the two things that I'm going to use, and I'm going to load into my VBO and the IBO. So I will extract the first part from these guys, right? So these are the vertex index, so I'm going to put that in indices. And these are the normal, well, this give you the surface normal here, so I'm going to convert that to the vertex normal. In this case, this is the first example I'm going to do. So how are you going to do the vertex normal, right? So I'm going to do this for the first time. So let's see how we're going to do, right? All right, so let's call function arrange, maybe arrange, right, to arrange everything. Okay, so yeah, that will do. And then now let's think about this a little, right? So I have this is also a single array, right? So it is on the one line each. So how are we going to nail this problem, right? So this is a logical thinking that you need a lot. So if I have something look like so here I have 1 and then 2 and then 7 and then 2 again, right? 2 again, and then 5, and then I have 2 again, right? So this is the order. So this is the vertex. So it seems like I have vertices on the even numbers, right? So this is a vertex and this is a vertex, right? So that means if I count from I0 to some value like 36, less than 36, right? And here we can get this equals 0 means even values, right? So if it's even, we'll put that into this one right here, right? So and then I subtract 1 because it's starting from 0, right? So I can do that. So that is that. So then that part is taken care. Then how can I put normals? These values I have to address onto the vertex normal. So that's what I'm going to do in this one, is addressing everything of the vertices. So that means if is I plus 1 is one of them, right? So this is I plus 1 position, right? So that is one thing, and that is the index. So this I plus 1 index will pick somewhere from this line right here, right? And so the 2 means actually 1, so it will be this one right here, right? Because this one is indexing from starting from 1, but here when you store it, you start storing in 0, so that means 2 means this guy right here, right? And so all these 3 has to go in so the first 3 is paired out. So this part right here has to be, right, this part right here has to be whatever the values I get into, which is this one. So this is what going to be in there, right? So I had to make a mechanism in order to get these here, right? And then the next time whenever I hit that, for example again at 7, yeah, so when the vertices, actually you have to compare with the vertices actually, where I'm going to store this one. Oh, it says at 1, right? At 1 means the 0th position right here, Actually, I'm going to store this right here, not the second one. Right, so this is where I'm going to store. This is wrong. This is wrong. Actually, that is a mistake. Right, so it has to be on your first three, has to be this value. Why? Because this is the vertex index, right? So the vertex index says it is 1, that means the 0th position. That means the start. So my normal values here will be that, and the corresponding value. So and then the 6th place, which is 7 minus 1. So the 0, if I count it from the 0, 0, 1, 2, 3, and so on. If you count 3 by 3, here it is, I think I have the 4th one is here, 0, 1, 2, 3, 4. Well, somewhere here I had to store that one, right? Okay, so so that is this one right here, and then the 5th one is somewhere before this guy, so I have another one, right? So like that I had to store this value, which is in whatever is giving here at this point right here, right? And then I had to take that value and store in this this normals array, but it has to match with the index that I'm going to use. Why? Because I'm going to do is I'm going to have my v value, and I'm going to have my n value next to that. So when I design my VBO, right, all the v's will be on the first one and the n's will be the corresponding value. So if this is the v first, this is the n first, so that is the order I'm going to put this. So because of that, I had to expand my normal index. It can be duplicates, of course. You can see now I will have 3 duplicates, but the thing is, since I'm going to take care of my model corner like this, and it's sharing with the other edges, right? So it's edge sharing at the edges like this. So in that case the surface value here will be different. Okay, right? So okay, let's write this. It will be a little bit tricky to write, right? The first thing I should do is make sure so I can write this, store the indices, right? So that's the first thing I can do, right? So let's have a counter int j, maybe 0, right? Yeah, so that is one thing. And yeah, so let's say for int I equals 0, I less than okay, how many elements I have? Well, 12 triangles, each has 3, that is 36, and the normals I have also 36 there, so it will be 72, right? 72 and I plus plus, right? And so that is my loop, and then I say in this loop if, right, if I equals not equals I percentage 2 equals this, that means all the even numbers. I'll do something here. What I'm going to do is the first thing I do is indices. In this is and the j is going to be equal to nothing but what I have there is int, right? Int, and this is I value, and then I'm subtracting 1 because array is starting from 0, right? Okay, so then I had to take care of my normal thing. So how can I do this? Normal, right? Normal, and what is the value should be here? That's the first thing I had to figure out. What is the value there? That should be j, of course. Maybe No, I had to store it on the corresponding index, right? So if it is 1, it should be here on this 3. But if it is 7, it has to be somewhere else, somewhere here, 7, right? And then the 5 somewhere here, maybe, right? So like that, I had to make a match, right? So that means I'm going to get my index value, which is I and indices yeah, indices going to be, I should have a short name there, but anyway, this is that. And yeah, so one thing is, when I say one index from here, that is a 3 of the values, right, in this one. So if I say one index, it will cover up to here. Whatever the next index will be, 3 times of that. So it's always jumping 3 index, because this is nothing but the serial number of array, just a serial number, I mean the serial sequence, just a sequence of one-dimensional sequence. So in that case, one value means 3 of them, so I had to store 3 of them here, right? And how am I going to do that? Well, I need three values for sure. So the normals, each time it will be 3, so let's have 3 values here, 1 and 2 and 3 for sure. Yes, I need 3. And then on this 3, yeah, so it is always, you have to multiply that by 3, so that means I have to multiply this by 3, and so the next one is multiply by 3 and add 1, right? Yeah, so add 1 there, and then this guy will be multiplied by 3 plus 2, right? Plus 2, right? Okay, so these are my point, the vertices that I have, and this is going to be equal to nothing but the odd value of my indices, and I'm going to get the coordinates from the other one, which is my normal indices. So what did I call here? It's called normals, and then this is called normal. Okay, that's fine. So the plus equal, obviously, so I'm going to add these, I'm going to add the normals together, and then I think I had to normalize it each time I do this, right? So okay, so this is what I'm going to do, and I'm going to take the values from the normals, right? Normals, and this guy also I'm going to take it from the normals. So let me take care of one first. So what I'm going to get here is obviously indices, actually the int up there, so it is int, right? I plus 1, so I plus 1 of the int, and yeah, so it is giving me actually it is up there, it's giving me only starting from 1, so I subtract 1 on this, right? And this value, and I'm going to multiply that by 3. Yes, so you have the one-dimensional arrays, so in that case I had to multiply this by 3 in order to make sure that I get the right position of the corresponding value. So it is multiply by 3. Okay, right, so this is that. Okay, so semicolon on this. Did I do it right? It thinks all the bracket matches, right? Yeah, and this and this. Oops, yeah, I don't need this one right here. I'm going to do, yeah, so I don't need that. So okay, so this is the first one, and the second one will be 3. You multiply this and add 1, right? So let's copy this, and right, and put it here, and the other one also, and then I'm going to add 1 to this guy and 2 to this one, right? And add 2 to this one, right? So now I have stored the values properly on my normal array, corresponding coordinates of each, right? And yes, you have to get the sum. So let's have something called sum here. I'm going to normalize my values, so I think well, it is a square root value, so it is anyway going to be sum, which is nothing but like that. And let's calculate that. That is a very complicated one, which is sum is going to be equal to what is this? Well, let me talk about that in a minute. Right now. So what I'm talking about here is oops, where did it go? Okay, all right, here. Right, so what I'm talking about here is if I get different normal surface, this is v1, if I have this one is v2, something like this, so it is v1 and v2, right? This edge right here is going to be nothing but v1 plus v2 divided by, right, square root of v1 squared plus v2 squared, right? So this is what it is. So what I'm doing here is calculating one surface normal, which is this one, and then I'm going to add the other one to that, right? So my existing one plus the new one, so that's what it is, right? Okay, so I think I had to calculate the sum in this order, right? So that means the existing square plus the new one. So adding those two together and then square it doesn't make sense. Okay, but anyway, so we'll look at it later. If it is really giving me trouble, we can look at it later. So let's do like this. You will get the idea what I'm doing here, right? So okay, so what I'm going to do is I'm going to have sqrt, and then there's the square root. Let's get the powers of each, right? And then the power, you have 3 elements there. I'm just going to add and then get the normalized value. Maybe it is wrong, maybe we'll see how the outcome look like, and you can play around with it later on. Okay, so I'm just doing this demo so you get the idea. These are not important parts. So right, so the normal here, so I call it normal, yeah, and what I have here, the indices, well, only these 3 I had to add. So one is this guy right here, right? And yeah, so let's get this one, this indices multiply by 3, right? Well, you can calculate later. I'm just putting everything together. Maybe it's not good coding, but yeah, just for you to see whether this demo works, right? So we have that indices, and yeah, and that comma here and 2, so that is one value, right? And then you have to add another one for this, right? So yeah, so this is 1 power plus again a power, and you will add another one, and again a power, you will add another one, right? So other things coming into here, well, the second part is nothing but this one, that is the power of second value, so that is that here, and comma 2, right? And then the third one is this, and comma 2, right? Okay, so that is the sum value. And then yeah, and then what I'm going to do here is going to calculate my normals. That means to be the same values divide by that. So let me just get copy of this and then alter it. I don't want to type much, type enough already. So yeah, these are not right. So so it should be the duplicate of the same, which is oh well, so a duplicate of this divided by sum, so that's what it is, right? So let's have that there, copy this and paste it here, and divide by sum, so that is 1, and the other one also the same, so no plus either, so get rid of the plus, and then here I have that, and divide by sum. Obviously you need a plus sign right here, right? And third one is the same looking, so get rid of this part right here, and then the plus sign, I don't need it. Oh, let me see this. Okay, so this is this, right? Yeah, yeah, so that is that, and then divide this guy by sum again. So those are the three things that I need in order to calculate, normalize my values, right? One more thing I forgot is increment my j value here. So where's my j value incrementation? Comes here. Yeah, so I had to increment my j, otherwise I won't get any values, right? Right, so this is j. Why? Because this one is running 72 iterations. I need only 36 of that, so I will keep a count locally, so that's why j is running. I think this will do. So my structure now, I will have two arrays here. One is my normals, right? And so this is indices, right? Indices right here, this guy right here, and that one has all the values starting from 0, right, index, and then go to 35, right? And then I have my normals, which is corresponding to my v's up there. So the each v of that I will have some normal values now, right? So the n values, and that matches my v values up there, right? So those are the things. This is the important part. This is what I was expecting you to do on this lab, right? So create corresponding v's. So that's what it is. Actually, this many lines, so that's all. But you have to do a lot of thought in order to do this, maybe, if you have no idea what you're doing, right? So now, yeah, we good. We have this part, and I think let's compile and see anyway, right? I don't know whether I have some errors on this, so let's compile this. Seems like it's all right so far, so good. Take some time, seems like, right? Okay, I should not jump ahead, so I believe it's correct. And then well, if it comes an error. Okay, so now we come to, oops, well, this won't work anyway, so I'll close that. Okay, anyway, so now we are in creating the VBO part, right? So how do I create the VBO here? When you're creating the VBO, what you should do is, the first thing is setting up my the handlers, right? So those are two handlers here, and then I'm setting two buffer types. So one is the element buffer. That is what you're going to use to put your index, and the other is array buffer, which is I'm going to use my VBO. We call it VBO on this. Actually, this is the index buffer, this is the vertex buffer. So I'm going to put vertices, right? So this is the vertices, and then I'm going to put normals just after that. So if I'll call it normal, actually that is what I'm using here now instead of normals. So I changed that code, right? So when you do this, what happened is this. So what is it happening? What happens here is when I create two memory locations, arrays, right? And then one is called IBO. So I have my IBO there. So then I generate it, and then I put some buffer type on it. So this is the type that I put it in there. And then I have my VBO handler, which is a VBO here, and then I have my handler like that, and then that is what I did. So the structure of that. All right, so then the next thing I did here is divide this to two pieces, right? So that's what this updata part right here and this right here. Okay, and then yeah, so oops, one thing up there, you had to change that part as well, otherwise you'll be in trouble. Now I have here is normal, not normals, right? So then I put my values on the vertex values here. So all the vertex values are here, right? And then the normal values are here, so it is corresponding values. So this is what these two lines right here do, right? So I put it those things in there, right? And it's corresponding values, okay? And right, so then if I have these two, so there is asking whether you want to do dynamic. I wrote it here dynamic. I should put dynamic here, so I will take care of that in a minute. And then this part right here is in this, I have to change this to indices, right? And then dynamic draw, and then you put this guy into this. So that's what I'm going to do, right? So that is the IBO data, right? So the index data. So the index data is one buffer, VBOs in another buffer. All right, so that's what I do. And then I clear my buffer structures, so it will be initialized. So that's what we do here. All right, okay, so there's nothing active in that case. Right, so let's do the changes. Little changes I had to do here, right? The changes are okay, normal, vertices are vertices, and then here is indices, so it is what I created, right? So indices, and then again indices here, right? Right, so if I do that, and then like to have my dynamic draw instead of static, maybe. So right, so I put that one here. Okay, so if you have textures, of course, textures also each coordinate, each vertex has one coordinate for texture, which is xy. So in that case I can extend this to texture as well. So but make sure you address each and every point and then apply every point means right here every point will have a normal and the texture, right? And then you can have it a corresponding value right there. Okay, so now Now everything is look alright, and then I have element buffer, so you can see the GL element array buffer, and then I have GL array buffer. So the GL array buffer is the one which is contains all the coordinates. GL element buffer is the one which is handling the index, right? Okay, so then when you're drawing it, obviously you come, I just create a new function for drawing and call this one in the array. You can do any the other way as well. So in this case, I bind my VBO, I bind my IBO, and then I'm setting up my clients arrays. So in this case, what I do is actually client array pointer means, oops, I have these arrays, which is nothing but the VBO part, right? VBO array, and then I'm setting my vertex to the top pointer, and then the corresponding value, which is if I have it some value here, the length of vertices will be the jump, so the offset is right here for my normals. So this is our V's, these are ends, right? The vertices and the normals, right? Okay, so well, so those are the two things that I'm going to talk about, I mean handling here. So yeah, so this is what the pointers are. So one is always on the start at the beginning, 0, and the other guy will be on right here, which is the length of words, right? So this here to here is what we call size of words, right? So size of words, and right, so that is what it is. So it will jump into this, right? And then okay, so I have this, and then I'm going to do is what, draw elements. I'm going to draw triangles, and 36 of them. So if I say the triangles, it will take care of my, it will come here. So eventually it will take my first 3 elements there, right? The first 3 elements, and then he will go and pick those values from here, right? So that's what it's going to do. So and then draw that, and then jump into the other 3. So like that it will jump into 3. So notice here I just gave 3. That means in here I have 3 values, of course, for the one of them. So it will jump 3 values down with the pointer, and then the normals, eventually it knows it's going to jump 3 anyway. So that's why you don't have to give in the normals, you don't have to give 3. 3 is always 3 you have to have for the normals. And for the pointers, yes, it can be 2 or 3. And this one says, okay, how you packed it? Is it packed tightly each other? Yes, it's packed tightly each other, so you put 0. If it is a loose, or if you have some values in the between, in that case you have to consider that. And this is the starting point, which is a 0, and then the starting point for this one is the offset, which is from this length right here, right? That's what is given here, right there, right? And then you draw, and then you reset your buffers, and then disable it, and again enable it. So that's the routine you going on here, right? Okay, so that's that, and then let's go and see what you draw here. Well, okay, so I like to let me think about it. So right now, if I do it like this, I want to translate everything by 0.05, so it will be come to the center, right? And well, I do the rotation and then I move it. So let's do it like this, and then have here negative 0.5. Why? Well, let me explain that in a minute, why I want to do this. Well, you can see my object is it's from -1, not -1, 0 to 1, right? It's always a 0 to 1. So in that case, when I rotate, it will pivot on the 0 position. so it will be rotate on around the axis. I want to bring this 0th position into the center of the box, so it will rotate around the axis, so it will be look good. So that's why I'm thinking of doing that, right? Yeah, let's just do it like this and see what happens. Maybe I had to move my z-axis as well, so we'll see about that. Right, anyway, so then you call draw VBO, right? One more thing I forgot to do is I create a function here called arrange, right? But I did not call this anywhere, did I? No, I did not. So yeah, you had to call that somewhere. So I'm going to do the initialization. Before I create VBO, I had to arrange my data. So data arrangement is the one thing that you have to write in your project as well. You read the data and then you arrange it. You can do whatever, however you want to do it. Right, so then yeah, so then the create VBO and then the drawing, I called it there. So let's see what happens when I run it. I hope no errors. I hope it will display something on the screen. I did not check my normals, right? Yeah. Hope, my fingers crossed. Let's see. How does it look like? Right. Okay, here we go. Ah, there it is. Alright, so this is what I have. So it's look all right, yeah, so this is my square, and then I can rotate it. Still it's going round and round, right? I think the normals are a little bit off, not that much, but you can see these lines right here. Let's look at this a little bit, but let me center it right. It's going off, I guess. That means I like to bring it to the center, and then so that will be look good when I'm doing this, right? So how can I bring it to the center? So let me think about that. Okay, so I have my push and pop. I had to arrange. How do I have it? Maybe let's get the z-axis. I don't know, just have minus 0.5 there, so that will be after pushing the values, and maybe that's all I had to do. Maybe it is off by this one. Let's see. Should come into the center, I guess. Right. Okay, so let me make it a little bigger. Yes, that is the one which is having a problem. Okay, so yeah, I think my normals are not calculated right. Maybe my normalization has an issue, right? And then yeah, but the squares are pretty looking good, right? One more thing I have to point out here, the structure of this model is not good, right? Can you see this? Right here I am sharing so many vertices in one point, which is like 6 of them, but on the other places like here I have only 4, right? And then here I have 4, so it might cause a problem too, but I'm not saying that is the exact problem. Well, I'm too lazy to debug this, but I want to teach you just how you're really going to restructure your data. So that's what the point on this lecture. Yeah, feel free to fix the things that you see here if you want. It's not, I think it is a very small error if it is, seems like, but most of it is look all right, I guess, right? Okay, so maybe because it is sharing one edges, some edges sharing more vertices than others, so the vertex normal might not giving you a friendly outlook. That means you have to do the triangle fix. There's a triangulation, proper triangulation options in many models. That's why when you do modeling, it will ask you to do removing unnecessary edges and make it in order, either clockwise or the anti-clockwise. So all these adjustments comes in because of those kind of artifacts. Unless if I do something wrong in my calculations, also you can see that problem. But you can see the edges are more smooth now. Why? Well, because I'm using the vertex normals instead of a surface normal. And if you're having a surface normal on this will be so crispy. Like for example, this will be really white and this whole thing will be really dark, right? So those are the things changes. So right, so I will stop here. I hope you learned something and you can do the project now. Oh, one more thing I had to address here is, okay, so that is for the surface normal. So what if I have only the I don't want to use it like this. I just want to use my the surface normals and the VBO. In that case, what do I do? Well, you can access any of the elements in your array using draw array. The option called GL array element, and then you just give the index value. In that case, you can draw anything that you want. So in that case, I can use instead of I'm just dividing this to pieces, I can load this whole thing as index, right? I can load this whole thing as index. I don't have to worry about changing it or dividing it to two pieces. I can use this one as a GL array element, right? So you store this and then you access this one as an array element. So in that case, these array elements are, if it is for I equals 0 to some value, right, 72, in that case this guy will be my vertex array, vertex element, which is GL begin triangles, and then you can give this value, and this value, and again this value, and this value on your vertices. And then also you can give the normals. You can access GL array element of this, and this. That is also possible. If you want to do that in that way, you can, right? And make this work. So that will be the surface normals. If I have time, if you're really struggling with that part, yes, I can introduce you that with another lecture. Let me know if you want use a GL array element and work on it. So then in that case it will be much more convenient, because here I'm just rearranging these in a one function, so you don't have to do that. If I really want to use as is whatever I have here, so that case you have GL array element and then the index. That's how you do it. Okay, all right, so okay, so I'll stop here, and if you have questions, please email me or the comment on the video, so I can take care of and answer you. Right, okay, so I will see you in another lecture.